Hi dear children, welcome back to our chemistry class. Next portion, characteristics of chemical reaction. Okay, chemical reactions are characterized by changes. Okay, so types of changes is the first one, evolution of gas, change of color, formation of precipitate. First, evolution of gas. In many chemical reactions, one of the product is gas. For example, that is, when zinc reacts with dilute sulfuric acid. Okay, so which gas is evolved? That is a reaction. Okay, we can take sulfuric acid in a test tube, add zinc granules into that test tube. Okay, so after some time, what you can observe? Yes, here some gases is evolved, that is brisk effervescence. So what is effervescence? The formation of gas bubbles in a liquid during a reaction is called effervescence. What is effervescence? The formation of gas bubbles in a liquid during a reaction is called effervescence. So dear children, zinc react with the sulfuric acid to form zinc sulfate and hydrogen. So what you observe here? Brisk effervescence. Okay, which gas is released? That is hydrogen gas. Is it clear? So zinc react with the sulfuric acid to form zinc sulfate and hydrogen. Which gas is released? Hydrogen. What you observe? Brisk effervescence of hydrogen gas. Is it clear? Next, potassium chlorate is taken in a test tube, then heated strongly. It breaks up to produce oxygen gas. How we can confirm oxygen gas is released? We can take small amount of fruit snacks, for example glucose mixture. Okay, so if we add this sucrose or corn syrup into that mixture of potassium chlorate, fire is produced. We know oxygen support for burning, oxygen support for combustion. Okay, this way we can confirm oxygen gas is released. So potassium chlorate is heated strongly. Which gas is released? Oxygen gas. Okay, oxygen gas is released. So how we can write the equation? Potassium chlorate symbol KClO3. Formula of potassium chlorate is KClO3. It is heated strongly to form potassium chloride. Potassium chloride formula KCl plus which gas is released? That is oxygen. Dear children, after that you balance the equation also. Dear children, we can take sodium sulfide in a test tube and it is treated with dilute hydrochloric acid. Here some bubbles is formed, that is a releasing of sulfur dioxide. How we can identify that is sulfur dioxide is released? Here suffocating odor is formed, suffocating smell is formed. That suffocating smell is the releasing of sulfur dioxide. Okay, so which gas is released? Sulfur dioxide. So what is the formula of sodium sulfide? That is Na2SO3 react with hydrochloric acid to form sodium chloride, water and sulfur dioxide. What do you observe? Bubbles and a suffocating odor of sulfur dioxide is liberated. Which gas is released? That is sulfur dioxide. Next characteristics of chemical reaction is by change in the color of the reactants.
Take two test tubes marked as A and B, and in each test tube pour about 10 milliliter of copper sulfate solution. Fix test tube A on the clamp stand and keep the test tube B as control sample in test tube stand. Now, take 3 iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube A for about 20 minutes and keep the third nail aside. After 20 minutes, take out the nails and keep them beside the unused clean nail. Do you observe any change? On comparing both the nails with the unused nail, you will find that the iron nails which are kept in the copper sulfate solution have developed a reddish brown layer on them. Now, take out the test tube A from the clamp stand and keep it beside test tube B for comparison. On comparing both the solutions, you will find that the original deep blue color of the copper sulfate solution has faded away. What is the reason behind these changes? When iron nails are dipped in copper sulfate solution, the iron metal reacts with copper sulfate, which results in the formation of ferrous sulfate and copper metal.
Example of changing color. We can take a test of 10 ml of copper sulfate solution, and in the test tube we can take hydrogen sulfide, and it is connected with a delivery tube, and hydrogen sulfide is passed through that, and it is combined with the copper sulfate solution. What you observe? Look in the. After some time, we can see a black colored substance is present on that solution. Okay, black colored substance. This black colored substance is copper sulfide. Is it clear that black colored substance is copper sulfide? That means copper sulfate is react with hydrogen sulfide. A black colored substance is formed. That black colored substance is copper sulfide, and sulfuric acid also formed. Clear now? Next example, lead nitrate. Lead nitrate color is white in color. Okay, this lead nitrate is heated strongly. What do you observe? Please look in the test tube. What do you observe after heating? We can observe that a reddish brown gas is released. Reddish brown gas is released. That reddish brown gas is nitrogen dioxide. Nitrogen dioxide. Is it clear that reddish brown gas is nitrogen dioxide? And one more gas is released. That is oxygen gas. How we can confirm that is an oxygen gas? We can apply the flame through that test tube, that is lightning. That means oxygen gas is also released. Clear? That is, lead nitrate is heated strongly to form yellow color of lead monoxide is formed, reddish color of nitrogen dioxide gas is formed, and colorless oxygen gas is also released. Lead nitrate formula PbNO3 twice to form lead monoxide, that is PbO plus. Reddish brown gas of nitrogen dioxide, that is NO2 plus. Colorless gas, that is oxygen. So, observation. What do you observe? Lead nitrate is heated strongly. What do you observe? Observation means that you must write reddish brown gas of nitrogen dioxide and yellow color of lead monoxide is formed. Which are the gases released? That is nitrogen dioxide and oxygen gas. Is it clear now? Thank you, dear children. Please read the lesson and write and study all the equations. Is it clear now, dear children? Take care. Bye-bye.